Good morning, my little buttercups. If you haven't done so already, please make sure you've completed your retrieval quiz for this lesson. So go to your student worksheet and complete the retrieval quiz. Come back once you've finished that for the answers. By giving you the answers, you can then self-mark your work from home. Okay, so the answers are as follows. The gas released by reacting a carbonate with acid is carbon dioxide. The formula for a sulfate ion is SO4 minus 2. Now remember, a halide ion is any ion from group 7. Excuse the spelling for iodide there. Number 4, we add silver nitrate when testing for halide ions. Number 5, if we're testing for sulfate ions, we use barium chloride solution. Number 6, silver iodide is a yellow precipitate. Number 7, barium sulfate is white. Number 6, copper ions produce blue precipitate. Number 9, we can use a flame test. And the challenge, add acid to the solution. Bubble the gas through lime water. If the lime water turns cloudy, it is carbon dioxide gas. Okay, so today we are looking at instrumental methods. The instrumental methods used when analysing chemicals. So you need to be able to describe the use of these methods. Some keywords. Instrumental method is a way of analysing a substance to find out what it is made of. Remember, a pure substance is made from only one type of element or compound, and a mixture is made from more than one element or compound that are not chemically bonded. Now, these two keywords you might have heard of before, you might not have. Qualitative is a test that identifies the substances present, whereas quantitative is a test that identifies how much or what the concentration of the substance is that is present. So just a quick topic overview as we are now coming to the end of our chemical analysis topic. As you can see, we've covered lesson 1 to 6, and today we are looking at lesson 7, which is the last lesson of learning for this topic. Okay, so as we said at the start, there's 2 different types of results or data you can get from experimenting. You can get qualitative data. Now that data produces us with results with quality. For example, they can give us names, they can give us colours, they can tell us whether a smell's been produced. So for example, chromatography can give us qualitative results because it can tell us, it can describe to us, we can see what components are in the substance, but we can't see how much of each component is present. So in chromatography, we can see colours. We know what colours are produced from different mixtures. Flame tests provide us with qualitative results. It provides us with colours that are seen from metal ions, but it can't tell us how much of the metal ion is in that sample. It can just tell us what metal ion it is. Now, on the opposite side, we have quantitative data, quantitative, referring to quantity, how much. So this type of data can tell us how much of a metal ion is present, the concentration of that metal ion. So quantitative data is numerical data, data that can be measured with numbers and statistics. So that leads us on to looking at what instrumental analysis is. So, instrumental techniques are techniques that use sophisticated machines to test and analyze substances. So, rather than uh, using techniques in the lab, for example, flame tests and paper chromatography, they use machinery instead. Now, the advantages of using instrumental techniques are it can give us good quantitative data. So it can give us numerical data that is more informative for us. It has a higher sensitivity than human lab tests, so it can identify small amounts of chemicals in a substance. So unlike a flame test that can tell us what substance is present, if we used an instrumental technique, we could find out how much of the metal ion was present. Instrumental techniques are much more accurate because the machine removes human error, and we can get faster results. Machines can collect large amounts of results in smaller amounts of time than humans can. So, what's the uses of instrumental techniques? Well, there's lots of uses in everyday life. They can be used in hospitals to analyse blood, urine, and tissue samples. They can be used to analyse the contents in food. They can monitor the quality of water and air, and they can be used to test the purity of medicines. So, two examples of instrumental methods we will be looking at today are gas chromatography and spectroscopy. So, as we've already mentioned at the start of the lesson, paper chromatography only tells us what substances are in a mixture. So it only gives us qualitative results. It doesn't tell us what the quantity of those substances are. So in order to find out how much of a particular component is in a mixture, we use gas chromatography. Now this is an instrumental method, and again, it's better than paper chromatography because not only can it tell us what substance is present, but it can tell us the concentration of that substance. So, task one, I would like you to watch the video on instrumental methods and then come back once you've watched that video. Okay, so what I would like you to do now is, after watching that video, I would like you to look at this chromatogram produced by gas chromatography. Now, remember from the video, the peak will show us if there's a certain substance present, but it can also tell us on the graph how much of that substance is present. So what I would like you to do is, by using this graph and this table at the bottom, I'd like you to have a go at answering these 3 questions about this gas chromatogram. Pause the video, come back once you've done it. Okay, so how many substances is the mixture made of? We can see that it's made of 4 substances. Which substance does it contain the most of? Well, that would be the highest peak, therefore that would be caffeine. Which substance does it contain the least of? Well, that would be the lowest peak, and therefore number 4, which would be sorbic acid. So now we're going to look at the second instrumental technique used in the lab, and we're going to look at flame spectroscopy. So this is a more accurate way of measuring the presence and concentration of metal ions in a sample. So what I'd like you to do is complete task 3, click the link and watch the video, come back once you've done it. Okay, so Just to go through the video on flame spectroscopy. Flame spectroscopy is an instrumental method that is a more accurate way of identifying metal ions in a solution. Remember, with a flame test, if you've got more than one metal ion, when you are heating that sample in the flame, it can produce more than one colour. The colours can be masked and difficult to identify. It can also measure the concentration of the metal ions as well, unlike flame tests. Now, remember, from flame tests, we know that each metal ion will give off light at a specific wavelength, and that's why it appears to be a certain colour. Now, if you remember rightly, white light can be split up into the visible spectrum, the colours of the rainbow. Now, each metal ion will give off light at a specific wavelength, which will relate to the wavelength of white colour. So if we look at the different metal ions, you can see where they give off light at what wavelength within the visible light spectrum. Now, we can use a machine known as a spectroscope to measure that wavelength that is being given off and then produce what we call a line spectrum. So you'll get a line, and that line will then refer to one of these metal ions, which we can then compare it with and identify. So we have the light being emitted, the source, the sample giving out its colour. It goes into a spectroscope, and then it produces what we call a line spectrum. And then we can compare it with known line spectrums to identify what metal ions are within our spectrum. So as I've already mentioned, each element produces a line spectra, which is specific to that element. So you can see you've got the wavelength at the bottom along here, and then you've got these absorption lines. And these lines will allow us to identify what metal ion is present. So if we got a result that looks like this, what metal ion do you think is present? So what you would do is compare this to known spectras, and you would decide which one it corresponds with. Which one is it the same as? What one do you think it is? Have a look. If you said calcium, well done. It would have been calcium. So task 4, I would like you to have a go at reading a spectrum, a line spectrum. So which two metals does the mixture contain, and how do you know that? So at the bottom, we've got an unknown, we've got our sample spectrum, and it's telling us that it's a mixture of two metal ions. Now we've got 5 known spectrums above for 5 known metal ions. I'd like you to compare it to those, and I would like you to identify what two metal ions are in that sample that we've tested. Okay, so now that you've done that on your student worksheet, let's go through the answer. So what you should have noticed is that there are lines on that are the same as the lines on lithium and sodium. Now remember, in a flame test, that would have been difficult to identify because the colours would have mixed. And also, lithium produces a red flame, calcium produces an orangey red flame, so it would allow us to identify between lithium and calcium as well. So that leads us on to the consolidation. What I'd like you to do is there are 5 scenarios. I would like you to explain which method should be used in each case. Now, if you are stuck, I've given you 2 boxes to help you. So remember, if I'm asking you to explain something, you must say why you've chosen that method. You can't just state the method, you need to state why you've chosen it. And so the methods you can choose from are in the red box, so you can have paper chromatography, gas chromatography, flame tests, flame spectroscopy, or the melting point. Now remember, we looked at the melting point at the really early on in this topic in terms of pure substances, because remember, pure substances should have a fixed melting point. So pause the lesson video, complete that task. Once you've completed that task, you then need to complete your RAG rating. Now, guys, for this consolidation phase, I don't have the green answers for you afterwards, because again, you might choose a different method to somebody else, but you might be able to explain why you've chosen that. So complete your consolidation, shouldn't take you any longer than 10 minutes, and then your RAG rating for the learning intention. Thank you, guys.